Assalamu alaikum students. Welcome to the lecture of chemistry. I am your teacher Sumayya Khan. Students, today we will solve the question bank for the chapter halogen derivatives. Let us start with the very short answer type question which will give you 1 mark for each. Now this chapter is for 5 marks without option and 7 marks with option. Let's solve the first question. The question one is to write the IUPAC name of the given compound. You can see in the picture a phenyl ring, a benzene ring is there, which is attached to a carbon and then to a bromine. Here at the junction we know that there is methylene group, that is CH2 group. So what we are going to call it? We are going to call it as a derivative of alkane. So this is your one carbon which will give it the name of an alkane, parent name methane. And bromine and phenyl group are what? The substituent attached to your alkane. So name of this is bromophenyl methane. As methane contains only one carbon, there is no need to specify the position of bromo and phenyl group. Obviously they are attached to that one carbon only. So the name is bromophenyl methane. Next one is to write the major product of the following reaction. A reaction is given where you can see that a cyclic alkene is there, to which we are adding HBr. Now whenever we are adding HBr to unsaturated compounds or alkene, we need to follow Markovnikov's rule, which we have studied in previous class. So according to Markovnikov, the negative part of the reagent, that is bromine, will go to the carbon that carries lesser number of hydrogen. So let's look at the carbons that will do the substitution. So always remember, whichever carbon is having unsaturation, the addition will take place at those carbon only. So this carbon and this carbon are what? They are doubly bonded. So addition will take place at this carbon and this carbon. Now let's see to which carbon the H will go and to which carbon Br will go. Now this carbon is attached to another group here, that is CH3. It is attached to one carbon here and it is having double bond with this carbon. So this carbon at this junction is making 4 bonds and it does not have any hydrogen. And this one is having double bond with this carbon and single bond with this carbon. So this is CH. So out of these two carbon, one is C and the other one is CH. So obviously this is the carbon with no hydrogen. Therefore bromine will go to this carbon. Okay. So I will write the major product would be what? It would be, here CH3 was there and Br will also come here. Okay. And hydrogen will go to this carbon and double bond will be removed because addition reaction has taken place. This would be your major product according to Markovnikov's rule. Next question is, write the correct decreasing order of boiling point. Now the correct decreasing order of boiling point, whenever you are asked to write that, now look at the molar masses of the compounds given. Here we have alkyl halides, all alkyl halides. Okay. Now the boiling point mainly depends on the van der Waals forces that keep the molecules together. And those van der Waals forces depends on the molar sizes or molecular masses of the compound. So whichever is having bigger size will have more van der Waals force and greater boiling point. Now in our example we can see that in all 4 names The alkyl group contain only single carbon. Okay. CH, C, C, C. All the four examples contain one alkyl group. Therefore, the mass of that particular alkyl halide will now depend on the size of and number of halogen attached to it. Okay. So in CH3Br, one halogen is here. In CHCl3, 3 halogen, 3 chlorines are there. Out of chlorine and bromine, bromine is bigger in size. Okay, remember it. Then we have CH2Br2 and CHBr3. We have to write the decreasing order. So we will first write the alkyl halide with the biggest size, which will show the highest boiling point. Now here, this CHBr3, that is bromo form, contain 3 bromine. Obviously it is going to have the biggest size and therefore its boiling point would be highest. So it will be CHBr3, then after that it would be CH2Br2, and out of these two, obviously bromine is bigger in size, but if there are 3 chlorine, therefore this molecule will become bigger and will have higher boiling point. And at the last we'll have bromomethane, that is CH3Br. So this is the correct decreasing order of boiling point for the given alkyl halides. Let's see the next question. Write the IUPAC name of the product B in the given reaction. Now a reaction is given, okay, and here A and B, you have to write the name of the product B. So for that you must first write what is the reaction. So let's try to write the reaction. Ethanol, that is alcohol, on treatment with sodium bromide in presence of H2SO4 will do what? Sodium bromide in presence of H2SO4 creates HBr during the reaction. Okay, and it results in the formation of Ca2H5Br, that is alkyl halide, and HBr is H2O is removed as the byproduct. This alkyl halide on treatment with sodium iodide in presence of acetone will undergo halogen exchange reaction and your Br group get replaced by iodine and you will get ethyl iodide as your product. Okay, this reaction is known as Finkelstein reaction. Okay, in Finkelstein reaction, alkyl chloride and alkyl bromide can be converted to alkyl iodide by treating it with sodium iodide in presence of acetone or methanol. Then the next question is, nucleophilic substitution of 2,4-dinitrochlorobenzene is faster than para-nitrochlorobenzene. You have been asked to give the reason. Now look, remember chlorobenzene or any halo monosubstituted benzenes are quite less reactive towards substitution reaction. The reason is that in case of halogen derivative of arenes, the ring is more stabilized due to the resonance effect. Now when any electron withdrawing group is present at ortho and para position, that less reactivity of that ring can be enhanced, can be lessened by that presence of electron withdrawing group at ortho or para position. So in case of 2,4-dinitrophenolchlorobenzene, the structure I am going to make, this is your chlorobenzene and this is your 2,4-dinitrochlorobenzene. Here you can see that A nitro group, which is an electron withdrawing group, is present at ortho as well as para position. When you compare it with the para nitrochlorobenzene, you will find that an electron withdrawing group is present only at para position. So due to the presence of more electron withdrawing group in case of 2,4-dinitrochlorobenzene, the resonance effect get destabilized and the reaction can easily take place. So presence of electron withdrawing, more number of electron withdrawing group in 2,4-dinitrochlorobenzene makes the substitution easier. Therefore, the reaction of 2,4-dinitrochlorobenzene is faster than the para-nitrochlorobenzene. So you have to just write that the presence of electron withdrawing, more number of electron withdrawing group in case of 2,4 makes it easier for the reaction to take place as compared to only one group in case of para-nitrochlorobenzene. Okay. Now let's see the next one. Name the reagent used to convert alkyl halide to ester. Alkyl halides can be converted into ester by treating it with silver carboxylate, and it will give you ester RCEO R plus AgX. So this is the name, silver carboxylate, name of the reagent. Now write the correct order of increasing ease of dehydrohalogenation. Now look here, 3 alkyl halides are given to you. This is your primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. So you have been given 3 different alkyl halides and the question is which one can be easily undergo dehydrohalogenation more easily. Now we know that alkyl halide on dehydrohalogenation produces alkene, and we know that when we do the dehydrohalogenation, there is a possibility that we can get more number of product, more than one type of product. So according to Setzeff rule, we have found that the alkyl halide which produces more highly substituted alkene are more stable. Now out of these 3, we know that tertiary alkyl halide will produce more highly substituted alkene and therefore it would be more stable. So with which the ease of dehydrohalogenation for tertiary alkyl halide would be more. After that, secondary alkyl halide will produce less than the tertiary alkyl halide, the alkene that is less substituted than the tertiary alkyl halide, and primary alkyl halide will produce the alkene which is least substituted. Therefore, the ease of dehydrohalogenation will also in the same manner. Tertiary will easily undergo dehydrohalogenation as compared to secondary and then as compared to primary. So this is the correct order. So today we have completed the very short answer type of questions with reasoning. I hope you all have understood it.